Hey there, this is Horner, and we need to go through the first 10 multiple choice for the 1D Kinematics multiple choice pretest. This first problem says a runner runs halfway around a circular track. So we actually need a circular track. So let's go ahead and draw a circular track. And there is a circular track. And our runner is going to run halfway around. So we're going to say we could either look at it where they run halfway around. So they go from here to here, the start and the finish. So here's start and here's finish. Or we could say that they have run from the start and they follow the track and they actually go over to the finish. What's the difference between the two? This is distance. This is what you probably would normally run. And then the other one would be displacement. So this is your displacement. They did tell us that the diameter is 100 meters. So that would be our displacement. And our distance, if you remember, the formula for the circumference of a circle is 2 pi times r, or 2 times the diameter. But because we're only going halfway around, our distance is going to be a little different. So we're going to put d is equal to 2 pi r divided by 2. The 2's cross off, and so our distance is equal to pi times r. Remember, radius is just half of diameter, so this is equal to pi times 50, or 50 pi. And those are your two answers. For number 2, this one says you've got to find the average velocity of a particle whose position varies as shown above. And actually, it's to the right. I realize that. So let's take a look at this one. We want to find the velocity. Remember, velocity is equal to change in position divided by the change in time. And because we have a straight line here, let's just pick 2 points. We're going to pick 2 easy points, that one and this one. This one because it's got a 0 in it. This one because it's in the positive half, and it's a little easier to deal with positive numbers than it is negative numbers. So we've got our equation, change in position, so that'd be final minus original position divided by the change in time. Our final position is 2, our original position is 0, and notice that we're going from a time of 4 to a time of 2. So we've got 2 divided by 2, and that would be equal to 1 meter per second. And that is your answer for number 2. For number 3, we're using the same graph again. It says, what conclusions can you draw about the acceleration of the particle? Well, there's only one conclusion that we can draw from the ones that they give us. They talk a lot about acceleration. And if you look at this, because it's a straight line, it has a constant velocity. And a constant velocity means that you do not have any acceleration. So there's no acceleration at all here. If there was, you would either see a parabolic curve, or remember we call that one Groot, but we don't see either of those, so there is no acceleration in this one at all. And that would be answer E on your sheet. For number 4, we're going to use the same thing one more time. Which of the phrases or words correctly describe the motion of the particle at t is equal to 2 seconds? So this particle, if you look at it at 2 seconds, basically what it's doing is it is not stationary. So that was one of the answers. It's not sitting still. We knew that it's moving. We looked at that last time. We know it's not accelerating, so we don't have to worry about it. It's moving in the positive x direction. So you'll notice that it is moving in the positive x. Okay? It is not moving in the negative x direction. Okay, so when they say that moving in, they really mean moving towards. So it's moving towards the positive x direction. A and B would not be true, so the answer here is actually E, and that one, believe it or not, is none of the above. Number 5. For number 5, we have a car making one complete lap around a circular track. So let's draw our circular track again. There we go. And because the car is going around a circular track, we know that the circumference of this track is equal to 1,000 meters. And it takes a time equal to 100 seconds. So let's find out what its speed is first. Remember, that is distance divided by the change in time. Our distance is the same thing as the circumference, so that's 1,000 meters divided by 100 seconds. So we have now an average speed of 10 meters per second. Right off the bat, we can cross off C, D, and E because those speeds were 0. The average velocity, we really don't have to worry about it. We know that it's 0 because it starts and stops at the same point. So our delta x, or change in position here, is equal to 0, and 0 divided by the 100 seconds would still leave us with 0. So the question is, does it have 0 acceleration, or does it have not 0, or does it have an acceleration? Well, typically we say that acceleration is equal to change in velocity over change in time, but we have to be careful because numbers don't tell the whole story. You'll see that as you travel around the circle, not only do you could have a constant speed, but you don't have a constant velocity. Your velocity is continually changing as you go around this. And because it's changing, even though your numbers aren't changing, your direction changes. And when you change direction, you are changing velocity. Because remember, velocity is speed in a direction. So you could actually say you're going 10 north right here. You'd be going 10 north. And then at this point, you would be going 10 west. And at this point, you would be going 10 south. So as long as your direction is changing, you are accelerating, and your acceleration is not 0. So the only answer we have is B. This one cannot be right. For number 6, this is the next question. The acceleration of the stone once thrown upward and leaves the hand of the thrower is, so here is your person, here's their hand, they throw a stone. Notice the stone has just left their hand. It goes up, and then it comes back down and hits the ground. Remember, on the way up, it slows down. So if the velocity is going this way, the acceleration has to be going in the opposite direction. When the rock hits the top, it doesn't have any speed at all. But when it gets here, it's actually starting to speed up. So it goes faster and faster as it goes down. And it goes faster because both the velocity and the acceleration are in the exact same direction. So notice that this acceleration and this one are both down. So once it leaves the hand of the thrower, this acceleration is always, 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 always down. So the acceleration is always down. For number 7, it says a ball is thrown upwards at the initial velocity of 20 meters per second, so we know that's VO is equal to 20 meters per second. Remember, if you throw a ball up, when it gets to the top, it stops momentarily, which means your final speed would be equal to 0. Our original speed was equal to 20, and the only other thing that affects it is gravity. Because the ball is going up, we're going to make that positive, which means that down is negative, so gravity is acting down at 10 meters per second squared. They want to know how high this ball will go. So for number 7, we need to use the equation VF squared is equal to VO squared plus 2 times gravity times distance. Notice we don't have time and we don't need it. That's why we're using this equation. Final velocity is 0. Original velocity is 20 squared plus 2 times negative 10. That's important. Times our distance. 20 squared is 400, so I'm going to move it to the other side. Make it negative 400 is equal to negative 20 times d. So our distance here is 20 meters. That's how high that ball would go. And that is your answer for number 7. It would be letter E. For number 8, it says a roller coaster increases, so there's a typo there, its velocity from 4 meters per second, so that's our original velocity, to 20 meters per second. So there's our final, and 8 seconds would then be our time. What's the average acceleration? Well, we have VF, we have VO, we want A, and we have time. So notice that we do not need and don't have distance. That's why we're using this first equation. VF is 20, our VO is 4, plus A times 8. 20 minus 4 is 16. Ooh, that's not very good. 16 is equal to 8 times A. So our acceleration here is a mere 2 meters per second. And remember, it's per second, so that's 2 meters per second squared. That would be letter A in your packet. Number 9 is the next problem. For this one, a car is traveling west. So let's go ahead and draw a little car. So here's our car. And this car is traveling in this direction. So here's our little person driving the car, and the car is going in that direction. We're calling this west. and it says that they apply the brakes. So we know that in a motion map, we have a speed that's pretty high, and then what happens over time is the speed or the velocity actually, because we're going to the west direction, will continue to get smaller. Our acceleration then for our motion map has got to be in the opposite direction. And it's constant. Remember, we always draw the same size arrows for acceleration unless there's no acceleration. So these are all going in the same direction. Notice that since this is west, this has got to be east. How do I know that they are opposites? I can draw my little axes here. We say this is north, where Santa Claus lives, south where the penguins are, east where Florida or New York is, and finally west where California is. So if I'm going west and I'm slowing down, then acceleration has to be in the opposite direction to the east. The last one we'll do here is number 10. And number 10 says a train has a velocity of 60 meters per second. So that's our original original velocity. So 60 meters per second. It is slowing at a rate of 2 meters per second. So if something is slowing, we're going to say that that acceleration is negative 2 meters per second squared. And our time here is equal to 10 seconds. They want to know what is the train's final velocity after that period of deceleration. So right here again, we don't have distance and we don't need it. So the equation we will use is just VF is equal to VO plus acceleration times time. We don't know what our final velocity is. That's what we're looking for. Original velocity is 60 plus negative 2 times t. That negative is pretty important for us to use here. And our t is actually, let's make it 10 seconds. So there's our 10 seconds. This would be equal to 60 minus 20. And so our velocity here is 40 meters per second. So that's the first 10. Next video we'll have the next 10.